This video is about graphing a quadratic equation when you're given the intercept form. We're going to look at the factored form of a quadratic and the zeros that it leaves behind. These zeros give us the solutions to the equation when y equals 0, and that's along the x-axis. So whatever makes these factors equal 0, that gives us our intercepts. So here's where we're going to begin. We have f of x equals -2 times x minus 1 times x minus 3. I'm going to look at this x minus 1 and watch how it matches the form of the intercept form, x minus p. In this case, the value of p is 1. Also, I can think through it this way. What value of x is going to make just these parentheses equal 0? That's going to be a 1. If I plug in 1, I get a 1. So what I'm going to do is go ahead and plot an intercept at x equals 1. And then I look at the next one, the same thing here. The value of q is 3, so that means I'm going to plot a point at x equals 3. Now, the cool thing about parabolas is that they're all vertically symmetrical. So I'm going to sketch an axis of symmetry that is exactly halfway between 1 and 3. Here it goes. This axis of symmetry happens to be at an x value of 2. So we can go ahead and write that down. We know our axis of symmetry is at x equals 2. It's exactly halfway between our intercepts. Next thing we can do is find the vertex. Now we already know the x value of the vertex. It's always on the axis of symmetry. So we're going to take that x value and plug it into our equation. So it looks like I found out that after plugging in 2 for x, the axis of symmetry, I get a vertex located at 2, 2. I'm going to take this vertex, plot that. Since my vertex is higher than the 2 x-intercepts, I know that there's no point that will be higher than the vertex. I have a maximum on my hands here. Next step, we can find the x-intercepts. We find x-intercepts when y is equal to 0. Wait a second. We already found the x-intercepts. Those are the zeros to the solutions to 0 equaling our function. So we can take those x-intercepts and write them down as ordered pairs. Last thing we're going to do to finish getting the rest of this graph is finding the y-intercept and then using symmetry to plot the rest of the parabola. The y-intercept occurs where x equals 0. So all I need to do is go back to my original equation and plug in 0 for x. So that means our x-intercept is located at x equals 0, y equals -6. And I notice how my y-intercept is located 2 steps away from the axis of symmetry. And that axis of symmetry works as a mirror. So I'm going to go another 2 steps to the right to find the corresponding point. And now you can really see the nice shape of the parabola occurring right here. So we'll go ahead and fill that in. Here we go. Second example. We're going to look at x plus 4 times x minus 2. This is in intercept form because I have a factored out equation or expression. I can find the zeros very easily from these 2 sets of parentheses. So first thing we're going to do, let's go ahead and find out where those zeros are, plot those on the graph. So we have an x-intercept at -4 and an x-intercept at +2 coming from the q value here. All right, now I got to think about the axis of symmetry where I'm exactly halfway between. I'm counting the steps here from -4 to 2, and it looks like I'm 1, 2, 3, 4, 5, 6 steps away. Halfway across that is 3 steps. So I'm going to go 3 steps from either side. 1, 2, 3, and that's exactly halfway at -1. So that's where I'll draw my axis of symmetry. So let's go ahead and write down what we know so far. We know so far axis of symmetry is at x equals -1. We also know that the x value of our vertex is on the axis of symmetry, so it should be -1 as well. So let's go ahead and write that much down. Now we just need to find the y value. What I don't know is where on the axis of symmetry that vertex is located. So let's plug in that x equals -1. All right, we got a y value of -9 when we plugged in -1. So that's where our vertex is, -1, -9. Since this is lower than the other two zeros, I've got a minimum. All right, you know what's great about intercept form? I already know what the x-intercepts are, so let's go ahead and write down these coordinates. Last thing we're going to look at is the y-intercept and then use symmetry to plot a corresponding point. The y-intercept, again, is going to occur when x equals 0. All right, we got a y value of -8, so that means when x equals 0, y equals -8. I'm one step away from the axis of symmetry, so I'm going to go one more step to the left, plot a corresponding point through the mirror. I've got a nice parabola going. All right, now we're going to put our knowledge of x-intercepts and vertices to use in the problem context. So here we have two guys, Justin and Chris. They're both in a track team, and they're measuring how high and how far they can jump. So we have two ways of representing that. We have Chris, his jump is represented by this parabola, this graph. Justin's jump is represented by this function. So we're going to have to take features of each of these to compare which one went further forward, and then which one was able to jump the highest. So I've made this little chart here to keep track of what we find out. The path of Chris's jump is modeled by the graph, and the x-intercept is at 6. So that means he went forward 6 feet, it looks like. And then if we look at the y-axis, the vertex, we can identify that at being at this location. The vertex is at 3, 4.5. X-intercept at 6, 0. So we have to look at the correct values. If I want to know how far forward Chris went, I'm going to look at the x value since that represents how far forward he went. So let's put that down in our table. The vertex is the highest point of a parabola. So that means Chris's highest point happened when he was 3 feet away, but the actual height was at 4.5 feet above the ground. So the next thing we're going to do is evaluate Justin's path. The first thing we want to figure out is how far forward Justin went. So we need to find the intercepts. We know that since Justin's equation is factored out, we can see the intercept form. So all we have to do is figure out what makes this first factor 0, what makes the second factor 0. I know these values make each of these 0 because I know something about the intercept form of a quadratic equation. I know that 0 is where he started, and then he went forward 6.2 feet. That's how far forward he went. So Justin gets a 6.2 for his forward movement. For the height, we have to figure out where the axis of symmetry is. Where's the halfway point of Justin's path? From there, we can plug that value in to get the height. How far up did Justin go? Let's do that. So I know that the distance from 0 to 6.2 is exactly 6.2. I need half of that distance. So 6.2 divided by 2 is going to give me a halfway point of 3.1. I'm going to plug it back into the original equation and solve. After I go through all of this, and I'd suggest using a calculator and get this rounded off, it looks like we're at a height of 2.883 feet. So let's put that in the chart that we have and compare. So after comparing the graph and our results from evaluating the intercept form of the equation, we can conclude that Justin went farther in his jump. However, Chris went higher in his jump.